This is a talk on writing zippy Android apps. I'm Brad Fitzpatrick, and we'll talk about writing zippy Android apps. There's the obligatory live wave that we can get to at the end for questions, or if people have questions anytime, if mics are set up, just blurt something out and I'll try to repeat. So this is basically the outline of the talk. I'll briefly say, who I am and why I care about writing zippy Android apps. We could talk about ANRs and what people call Jank. What is a janky app, which was the original title of my talk, which they changed to zippy. Talk about some new and some old Android SDK features to use to avoid jankiness, and some general numbers to know, and new things that are in Froyo to help you measure this stuff, and actually some war stories from optimizing Froyo. We'll just do Q&A. But notably, this is not a talk about the JIT, and not a talk about like V8 or anything like that. So if you're CPU bound, probably not the right talk. This is about making responsive apps. So me, I'm Brad. Prior to Google, I did a bunch of stuff around like social and backend infrastructure stuff around like memcache and file systems and also social stuff. And then at Google, I got sucked into social stuff for a while. So I did this like social graph API and profiles and Hubbub. But really, I like open source. So I'm back to hacking on Android now and back to hacking on open source. So I joined the Android team because I wanted it to be faster. I believed in it philosophically, and I wanted Android to succeed because it's open source, but I didn't want it to fail in the marketplace because it was kind of janky and non-responsive. So that's me. So Jank, I keep saying Jank. Let's see if this thing works. So Jank is what the Chrome team calls like stalling the event loop or being like not responsive. So the Chrome team is awesome about this. They only do like asynchronous messaging between processes all the time, and they never really do any like blocking function call. Android, historically, not so good about Jank. So there's a lot of places, Android kind of lets you get away with stalling your event loop, your UI thread for way too long, and it doesn't, the documentation, in my opinion, isn't as strict about telling you like what thread things happen on and what you should defer to later and all this. So basically, this whole talk is about not being janky, being fast, doing work in the background, and minimizing the amount of work you do. A lot of it is about I/O and not doing too much I/O, and that Flash is slow and stuff like that. So this is the ultimate worst case. If I'm sure you've seen this from the docs or you've seen it in your own app. If you've ever seen this, that means you're doing something wrong. This isn't like a bug in the framework. This is saying some event is happening on the system, like probably a key press or something, and your application is not responding to it. So this means like there's one thread on your main thread is your UI thread that's sitting there waiting to process events. And if you're doing something else, like a network request or a really slow database query, this comes up. So this is like the ultimate worst case of Jank. This is like, I think, after 5 seconds. But even under that, users will still be like, this app is kind of weird and non-responsive. So what I just said. So yeah, it's 5 seconds for an activity, and if it's a broadcast receiver, which also by default will run in the same process as your activity. If you have like a broadcast receiver and a service and activity, they'll all share the same main thread. So responding to a broadcast receiver in what you think is a whole like maybe separate isolated environment, or I used to think that, is actually stalling the same event loop that your activity is on. So it's really important to either use separate processes or don't do that janky thing on your main thread instead. So the worst cases are typically network requests and slow disk operations. So some numbers to put things in perspective. I think these numbers were on the Nexus 1. Switching back and forth between two processes, so basically a context switch speed. This is Dalvik to Dalvik, just writing a byte along a Unix pipe. It's about 0.04 milliseconds. So context switch speed is about that. Doing a binder call, which is like the RPC mechanism on Android between two processes, about 0.12 or less. We had a regression at the end of a.a., and most of Froyo was like twice as slow. And then we found the bug right at the end of Froyo, or the performance regression. And it got it back down to, I think, even less than that. Reading a byte from Flash varies if it's uncached. It's not in any of the kernel caches, between 5 and 25 milliseconds. Writing, on the other hand, writing is all over the place. Writing is extremely slow. And the next slides will go into how slow writes are. And as far as what is perceptible to a user, there's some numbers about like frames of video and what the human perception of a slow action. Like at Google, we try to make all of our web properties be like under 500 milliseconds or under 250 milliseconds, because that's like what a user really notices. If it's over that, users drop off and users complain that things are too slow. So network, on the other hand, network's like ridiculously slow, or it's all over the board at least. So never, never do any network requests in your UI thread. We did an experiment through Froyo somewhere in the middle of the development cycle to see how slow file systems got, or how slow the NAND got as your file system got more and more full. Because I was always complaining that my phone was incredibly slow. And it turned out all my disk space was used up. I only had a little bit left. And it turns out the file system gets incredibly slow as it gets full, because it has to garbage collect and move stuff around on the NAND. Because unlike typical hard drives where you just read and write, those are the two verbs you can do to 512 byte sectors. Flashes, or NAND parts where you run a flash file system on it, there's erase, which is really slow, write, which is kind of slow, and read, which is incredibly fast with no seek time. So those writes and erases are terrible, and it has to do that more as it shuffles things around as file systems get full. So if you have a phone and you think it's kind of slow, first thing I would recommend is moving a whole bunch of apps to the SD card now that you can in Froyo. Your phone will get a whole hell of a lot faster. Sometimes people say that factory reset makes it faster. It's the same thing. You're deleting a lot of stuff from your data partition. So yeah, those are two different phones. The point isn't blaming phones. They all have different parts, speeds, but the curve is about the same. So we'll probably be more aggressive past Froyo. And right now I think we warn at 15% that your data partition is filling up. We're probably going to shift that, or maybe auto migrate some apps to SD card or something, or warn more aggressively. Anyway, the nutshell is performance varies a lot. So let's talk about SQLite performance. You probably should avoid writing in your UI thread, because writes can take a long time, even a single byte, and SQLite likes to write a lot. So if you don't know what SQLite is doing, don't assume it's magic. It does oftentimes quite literally what you tell it to do. So there's things like explain and explain query plan that you can see what stuff's doing. So let me pull up. We're going to bounce in and out of demos here. I wrote a little app here for this talk. The code is at code.google.com p-zippy-android. So you can go check that out. So basically, this app just does a lot of bad things that we can then introspect it, and we can see what tools are available. So well, let's start with some of the other ones. Here's a button that does nothing. It's quite exciting. It's actually literally hooked up to nothing. Here's a button that's like 600 milliseconds. So that was noticeable. I just made the screen go red so you can kind of feel it. But this button actually stalls the event loop for 600 milliseconds. This one, on the other hand, does for 6 seconds. So notice if I click around, these buttons aren't working. They're not doing anything. And it's kind of working, but kind of not. And after about 6 seconds here, or 5 seconds, there it is. So basically, the framework was like, hey, we have all these events piling up, and you're not responding in more than 5 seconds, so do you want to force quit this? So that was just a sleep in there, in that 6-second one. But let's play with databases. Let's make a little database here. And meanwhile, we'll switch over to a shell while that's still going. All right, more than one device. Let me unplug this other phone. All right, so in data.com.google.io2010 zippy, which is my little app, we have this. There's my demo database. So that just made a little, must have meant this one, demo.db. So I made a little 5 meg database here. So we can pull this. So you should always look what's in your databases and kind of understand their structure. So databases. So the SDK actually comes with SQLite, the same version that's on the device. So I can run it host side. And you can see that it's in, I don't know, is that readable? We can make it a little bit bigger. All All right, so we can go in here and look at the database that I put on there. Look at its schema. It just made a little table called foo with a primary key and 2 properties and a big junk column. And I just put a junk column in there to put a big thing just to make rows big and to make it 5 meg. And I put an index on property 1, but not on property 2. So now we can do fun stuff like, well, maybe select count from foo where prop 1 equals. So I just populated all of prop 1 and prop 2 with random numbers between 1 and 100. So we can see that, 6 rows there have 57 of 500 total. And here's another column that has 5, about the same. So if you're ever curious like what those queries are actually doing, you can say explain. And so property 1 is the one that's indexed. And you can see this is SQLite's internal bytecode that it steps through. So that's a little hard to parse. But explain query plan is slightly different. Where you see table foo with index, prop 1 index. So that's a little bit more readable. You can see what's going. I mean, this is a really simple table. Sometimes people have views and views and views of joins and selects. And you probably shouldn't do that. SQLite isn't as magical, like I said, as you think it can be. So if you're thinking it's Oracle or something, don't. Just treat this as simply as you can if you want good performance, in my experience. Let's do this. Oh, yeah, there's no read line here. Do this on a different index, 57. You'll see something different. Oh. Explain query plan. So here's the one that just had table foo. So sometimes it's kind of hard to see what's actually going on. So one tool that I found useful and I put on Zippy Android on the Google Code project is I have this little SQLite wrapper where I give it a database. What was it called? Demo.db. And I could do a query. Let's say this one. And it could tell you, it basically runs it under strace and then parses the strace output. And it's just like, I mean, you can see the script. It's just like a page of ugly Perl. But you can see that it did 65 reads, and it ended up reading 64K of data. Change this to like property 1. You can see it read 3K of data and 5 reads. So I kind of like when I'm testing queries and I'm not quite sure what the SQLite query optimizer is going to do, and I want to like convince myself that it's actually doing something more efficient. You could do explain query and explain query plan to like kind of see that it's different. But if you really want to be sure how many bytes it's sucking in from Flash, I find this to be helpful. So this is the tool I've used. You can grab it. The other fun thing to look at is proc YAFs on the device. The file system that these things run isn't like X3 or FAT or something. It's actually a file system called YAFs, yet another Flash file system that runs directly on top of the MTD, the memory technology device, so the Flash part that actually does raw reads, writes, and erases rather than work in terms of sectors. So on the device, you can shell cat proc YAFs. You can see all these stats here. Like, here's the system partition. This is the read-only one that OTAs come to. And here's /data, the user data device. And you can see, for instance, the page writes, reads, and erasures. Erases are the really slow operations. Page reads are pretty fast. Writes are not as fast. So it's also kind of interesting to watch this as your app runs and see like how often it's reading and writing. I mean, this is global on the whole system, so try to like turn off your sync and turn off other parts of the system you don't need while you watch this. But that can be a useful tool as well. So maybe we'll jump back to SQLite towards the end. But so far, what I wanted to emphasize is that writing to disk is slow. You shouldn't do it on the main thread, and writing to the network is slow. And even if your app seems to work, especially in the emulator has very different properties sometimes than the actual device. For instance, the CPU can be a little bit slower on the emulator depending on your machine, but I/O is incredibly fast on the emulator compared to real parts. In this app here, one of the other apps in the Google Code project is this thing I wrote a while ago called IO Droid. These just read and write a single byte. These are like immediate. Like writes are 1 millisecond in the emulator. It's just not true in reality. I'll put this on the other device later, and we can see that writes jump all over the place. And SQLite, in turn, does tons and tons of writes. So don't trust a millisecond or even 20 milliseconds, because it's gonna add up to quite a bit. Wasn't it? So yeah, things will be slow. Some users will have weaker devices or data partitions that are more full. So pretty much doing any writing or network on your main thread, even though it works most of the time, is pretty much a recipe for an ANR at some point. Or worst case, you work at Google and I'm just filing lots of bugs on you, which is basically what I've been doing the last several months. So tools, things that you can use to avoid running into ANRs. So the first one is AsyncTask. This has been in the SDK for a while. I forget the exact version, but at least like Cupcake. So the docs say that enables proper and easy use of the UI thread. So basically, you don't have to deal with handlers and sending messages to handlers. It's a little less efficient than doing it yourself, but it makes it really dead easy to react to some event on the UI thread, kick it off to a background thread that you don't have to create, and get the result back on the UI thread later. So the example that's in the docs is downloading some files. So you call this, or you create the async task like this. You instantiate the task once, and you send it some things to do, which is parameterized by the URL. So it basically has 3 template parameters: the type of work to do, which is often void; the progress update as the thing is proceeding, which is often void, but in this case it's an integer; and then the final result of the computation, which can also be void, but in this example is long. So the framework, when you make an async task and instantiate it, and call execute on it, will run your do in background on some background thread. Then you return some result, but you can occasionally say publish progress as you go, and that will also come to the UI thread. On progress update runs on your UI thread when it gets a message from your background thread, and that's optional. You don't have to override that. And on post execute is your final one. This is also called on the UI thread. And then you can do other things like mess with the view hierarchy, or, and change widget states and stuff like that. So that's pretty much the best practice way to do something in the background. Sometimes people, for instance, this is code in Froyo's browser. There were a whole bunch of ANRs in the browser that we fixed. Sometimes it's as simple as fire and forget, like doing something, writing to something to the SQLite in the background. This was handle web search request, and the code was pretty much, it got passed into content resolver, and then in the background, we updated the visit history with the content resolver out of the search URL, and basically it was void, void, void. And we just in the background, kicked off writing this to SQLite and then returned immediately. So a whole bunch of stuff like this went into Froyo. Some caveats. It is, you have to have a handler around. You have to have a main thread. So don't just go stick this in libraries just to be safe. Like if you have some library that needs to write to the database, be like, oh, well, I might be called from the UI thread sometimes, so I'll use AsyncTask. Because if you try to use an AsyncTask and there isn't a looper around and you're not on the main thread, it'll kind of blow up. It will blow up. So don't do that. Also, if you have to do something important that's like the user would expect to be persistent, if you call this from an activity and the user leaves your activity and your async task is still running, the system is like, oh, that's just an activity. That's not important. I can kill that to reclaim the memory and reinstantiate it later. So only do this if it's not really important. If you need to do critical stuff, use instead intent service. The docs in a.k.a. were actually really terse, and no one actually used this. We grew up through our own code base, and it turned out despite this being in the SDK, we actually never really used it ourselves because one guy knew what it meant. So Jason filled us in, and now the docs have 3 paragraphs instead of 1, and it says. So I'm not going to read all this, but basically it's kind of like async task, but it starts up this ephemeral service and does the work in the service, and then the service, when it's out of work to do, shuts down. And because you're now running a service, your process is special because you have a service running in you, and the system isn't as apt to kill you to reclaim memory. So yeah, you have a service running. You won't be killed. Anyway, it's a really easy way to use a service. Everyone thinks oh, Android background stuff, it's so hard because it's client server and you have to write servers. And by default, when you add a service, it's just some other object that's in your process. And by default, it's in the same process. They're actually really lightweight. If you want to make it a separate process, you can. But So here is one use I found of intent service. Calendar, at some point, has some broadcast receiver, and it gets something, I don't know. Somehow it has to dismiss all alarms for some reason. Maybe, I don't know, maybe you hit the dismiss. I don't really know this code. But for some reason, they need to dismiss all alarms, and they have to update this content resolver, and this is probably some SQLite query in the background behind this content resolver on the content provider side. So they on-handle this intent, and they don't even use the intent. Basically, they use the class as like, we do one thing, we just delete star or whatever. So that's like the simplest use of intent service. So it kind of feels like AsyncTask. It doesn't really have return values. Anyway, other miscellaneous tasks. Disable UI elements, like immediately when user does something, even if you have an async task, just so the user knows like you're working on it, you heard them, you felt their touch. Do some little animation or something, or progress dialogues, or some combination. Like if you don't know how long it will take, flashing up a little modal dialogue for like 10, 20 milliseconds and going away immediately, it could be kind of jarring. So you probably only want to do some like disable the UI element and spin some animation, and then only bring up a dialogue if it's actually going to take a while and you want to convey progress. So going back to this little demo app, I could show some of these techniques. This button, we showed the janky one and the ANR one. Here is a slow one that uses async tasks. So notice it immediately goes gray, and up at the top, there's this little thing spinning. So that's like the user's like, oh, OK, I see something moving. Something must be working really hard for me. So, but notice this. Like, I'm going to click async task, and you'll see the little spinny thing, because that animation is happening on the UI thread. But then I will go hit janky button, which will still be responding, because the UI thread is free. But then watch that the animation stops when I hit the janky button, because I'm killing all animations on the phone because I'm stalling the UI thread. So one janky button can make your whole app kind of be janky. Speaking of janky stuff, this is how you kind of want your list views to feel. Like they're kind of like fast. And the problem is lots of people do like database lookups or binder calls or something in their populate view or list, whatever it's called. And then their list views ended up looking like this, where it's kind of like chop, 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 chop. That's another janky thing. Whenever it's not smooth, it's not really responsive. Anyway, so what you should really do, and apparently I went to the list view talk yesterday, and apparently I'm doing it wrong. So don't copy my code. But basically, the point is you should do it async. You should populate. So this simulates that we're still smooth, but there's some like loading that needs to be done. One thing I did in the Cupcake release when I was 20%ing was the MMS app was doing database lookups on the UI thread. And so scrolling your SMSs was like chunk, 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 and sometimes with ANR. So I did all that async, and that's when, like, when you scroll SMS, you see like dot, dot, dot while it's loading, and then like the text comes in later. It's kind of hard to do that with list adapter. Well, it was until I saw the talk yesterday about the proper way to do it on data notify change or whatever. I'm not really a UI guy at all, so this might have been one of my bigger apps I've ever written. OK, so those are the 3 list view examples. OK, so other non-Jank related tools. This stuff you probably know about. It's pretty well documented in the SDK Traceview. If you are CPU bound or you're not quite sure what's going on, you used to have to use Traceview, you used to have to say like start and stop method profiling in your code. So you had to explicitly like rebuild your app to go add these start and stop points. But now there's a way, or it's not that new, but as of a release or 2 ago, there's a way to do it at runtime with the AM command that's on the phone. So we will demonstrate profiling the browser here. So let's bring the browser up. We'll bring a shell up. All right, so you see the browser running. So we'll run ADB shell AM, which is activity manager, profile, and then the process name, com Android browser, start, and the file name to write the trace to. So we'll write it to the SD card. So I'm going to start that profiling. So that sends a message to the process being like, yo, turn on your profiling. And we'll go to something here. Wow. I'll scroll around a little, zoom in a little. It's using a lot of CPU. Oh, I even have Ethernet up here, I think. I didn't even use that. OK, so assume it did some stuff. Then you can say stop. And now it'll flush out the trace from that process. So this actually will make your program run a little bit slower. So now if we look at SD card, you see there's the trace we just did. So we could pull that. Pull foo2.trace. Now there's Traceview, which comes with the SDK. And you could look at foo2.trace and see what was happening during that time that we were profiling it. So you can see all the different threads that we're running on the phone. There's your UI thread, some binder threads, and there's your AsyncTask thread, and some, I guess there's a cookie manager in WebView. I don't really know this code. But the cool thing is you can see all the function names down here. And you can see how many times they were called. And so sometimes it's interesting to sort by number of call sites or number of calls, being like, why was string.length being called 5,000 times? But that's probably a common one. But sometimes you see surprising things, and you're like, what? I thought that was cached. Why is that thing being loaded 1,000 times? So sometimes it's useful to sort by exclusive time, and you could drill down into all the children. So this is good if you're CPU bound, but the JIT and stuff like that should help with this anyway. Sometimes, though, this can give really confusing numbers because it kind of skews everything. It doesn't really adjust for the tracing overhead. So sometimes you have a small method that is actually fast, but when you look at it in Traceview, it seems to suggest it's slower than it is. So I'll talk about some stuff that's coming up later to kind of fix that by Reddit. All right, so yep, Traceview is good. Other thing that never hurts is just some print here with a Android util log. A lot of people make like a little struct that just has a wall time and a CPU, like current thread. There's Android system debug VM thread CPU time nanos. So you can see like wall time versus CPU time and put it at various points of your program, just to see, oh, that little function that looks so nice and clean, it turned out calls abstraction hell and ends up doing tons of CPU behind your back. So we found some surprising things just dropping these around. I've seen a whole bunch of one-off like structs that do this. There's actually a class performance collector in the SDK, but it's hidden because it wasn't quite polished. So at some point, I'm sure we'll make that public. It turns out no one actually used it anyway. So just watch your own device. What we did, so what I've done over the last 5-6 months is we added a bunch of instrumentation all over in Froyo. I went and added instrumentation to all database queries, so all of SQLite, all binder queries, all RPCs between processes, content resolvers and content providers, and also had the Dalvik team add logging on mutexes that were contended, so we could see if that was a problem. And indeed, each one of these found tons of surprising things. And so we logged for each of these whether or not we were on the main thread, what was the thread or process name, what version of the build, because we have like new nightly builds every night. And so everyone's trying. And then we have like weekend builds for like non-Android team members, like more Google employees. So we log a small percentage of these events as a function of how slow it was. And every day, like every Google employee was uploading a couple meg a day. And then it would go up to Google log analysis stuff, and I would generate a bunch of reports, and just found tons of fun stuff, where fun is totally broken. But that's hopefully mostly fixed. Now the problem is making sure we don't regress and trying to automate the process so things are detected quickly when we regress, and so that doesn't happen. So let me show you some of these. So for instance, here's Android util binder. Here's the binder call. Basically, literally all it kind of does is look at the uptime millis, of the phone, do the binder call, and then afterwards conditionally log it. And conditionally logging it is just, if it took over 500 milliseconds, this one's hard-coded to be 500. Some of them we made tunable, but this one was like kind of low-level enough that making it tunable was a pain. And then, if it was super fast, we wouldn't log it. If it was, anyway, then we would log all the stuff, the process name, and blah, blah, blah. So we did that to content resolver in here. Like whenever you're querying something, you'll see stuff in the source code later about like, look at the time before and after, and we've done the databases, logging stuff there. So you can see like system properties. For instance, if you want to, this is in the SDK, and it's part of the Froyo SDK now. So if you want to go see your own, I'll show you how you can set these properties, DB operation threshold millisecond. By default, it's on at 500 milliseconds, but you can turn that way down while you're debugging your application to see everything. So let's see some of that. So here's my app again that's supposed to do slow stuff. And we populated the database already with 5 meg of stuff. So let's logcat. All right, let's actually maybe bring up another logcat here. This one will be the event logcat. So I actually have there's actually 2 logcat buffers that are notable. There's also like the radio logcat. Basically, they're all separate ring buffers that are in the kernel, just in memory. The normal logcat that you get from Android util log is just big strings. You pretty much just like say things that are human readable. The other one, the event log, is more for like the platform itself to use, and they're all structured stuff. So they have names and numbers, and these are all like some packed binary structure. So this button starts 2 threads that are fighting over the same mutex. And because Dalvik is logging slow mutexes, please wait, mutexes are fighting. You can see DVM lock sample, Dalvik virtual machine lock sample events are going by, and you can see that in process com Google IO zippy, it was not the main thread. In fact, it was called thread 14 or 15. So these were the 2 I started up and down. It took 184 milliseconds, and it was at this file and this line number. And because of how I have the logging set, it logged 100% of these. So this is how we extrapolate when we subsample. So you can actually see, I set this slow by setting on the phone data.local.prop. So there's something called system properties on the phone, which is different than settings. System properties are like global things that are in memory. So if you say ADB shell get prop, you can see all these things that are set generally by the phone manufacturer as kind of like part of the build. But they actually are tunable, and if you're root, you can change these. So this file data local.prop, you can override them. So in the emulator, if you set this and then reboot your phone, when this comes up, ADB shell get prop grep Dalvik, you can see that indeed the lock profiling threshold is set to 10 milliseconds. By default, it's 500, but that would make for a much slower demo if I had to have mutexes fighting for 500 milliseconds instead of 10. So that is the DVM lock sample one. Let's also show initializing a database here. So it's going to drop it. Now you can see some database sample things. So the event there is database sample. There's the database name. If it has an email address in it, the email address is like cleaned up, so it doesn't like leak any stuff. There's like the first n characters of the SQL query. You can see the placeholders there. You don't get the placeholder values. And then you can see how many milliseconds. This was the name of the process or thread it was blocking. And if it wasn't, as this one isn't, it was on a background thread. And this is the subsampling percentage. So you can turn this one way down too. That's in the code as, here, let's show that. So there's this DB operation threshold milliseconds, and right now it's set to 500. But we can go on the phone and say ADB shell set prop, and we'll set this to, I don't know, 10. Make it really spammy. Make sure it was actually there. Show. Oh, Helps to actually run a command. Anyway, so you can see that now I have Dalvik and database samples set at 10 milliseconds. So this was cached in a static variable, so I will exit my app and restart it. And now we have the, here's the event log again. I'll do some selects. So this one is not using an index, and so you can see them going by occasionally. DB sample, you can see the select primary key, it took like 5 milliseconds. This one uses index, and this one I would have to bang on a lot for it to show up statistically, but there's one. So if you set this slow enough, you can get, and like I said, I/O on this thing is really fast. If you're using an actual device, your reads and writes will be a lot slower. For instance, here's a write where I update everything. I think this will take like 3 or 4 seconds. So now you see this update go by. Update foo, and this one took, 3.8 seconds. I was just appending a character to all the junk rows. So these are fun things to look at in your app to see where you're doing slow things that you're not expecting. So we did that a lot in Froyo. Blah, blah, blah. Yeah, we talked about log versus event log. And those are all the events that were added. The database samples, binder samples, content providers were broken into queries and updates based on how we wanted to structure it. And Dalvik lock contention when you're acquiring the mutex. We don't currently have instrumentation for who was holding the mutex the longest to kind of like find the person that was to blame for it. But generally, it's pretty obvious from your code, but we'll probably be adding maybe DVM unlock sample or something like that. So coming later, this is all speculative. This is all kind of things I want to do. I haven't totally prioritized all this stuff. Need a lot more instrumentation. Every time that we've added something, I've found more and more things that I want to instrument. Or like I've always found offensive things whenever we added instrumentation that was surprising. So I just want to keep adding more and make more dashboards. I also want to make all this sort of stuff easier to use, like the actual SDK platform features for end developers, rather than just like this kind of hacky thing you have to do with set prop and changing all these things and rebooting the emulator. It's not quite easy to use now. I also want a strict mode. Right now, the documentation doesn't really tell you what thread you should do stuff on often, or sometimes it's ambiguous how you should do stuff. And sometimes the view system crashes if you invalidate a view on the wrong thread. But other things of the view system you can do off the wrong thread. And sometimes you get away with it, and sometimes it happens to cause a repaint, and then you explode. So I don't know. I basically want a strict mode where you blow up early, so you can like maybe add in your manifest like strict mode, or call Dalvik OS debug set strict mode, and maybe blow up if you do writes on your main thread, or blow up if you do networking. Maybe give you granular control over when you blow up. This is all stuff you can do yourself now if you just drop in like a little sanity check functions at key points, but it's kind of a pain. I also want, you saw during the keynote that thing where show Android feedback, or go whatever. In the market, you can see all the stack traces from things that crashed in your users' apps. I kind of want to do that for performance data. If you could figure out a way to maybe let users opt in to performance collection and upload that to the Android market, so you can go in and be like, oh, these are the files and lines and mutexes that are making my app slow for my end users. I think that would be kind of cool. This is what we have now internally, but trying to figure out how to surface that in a way that doesn't kill people's networks and batteries and privacy. That's just harder. The other thing I'm excited about after Froyo is SQLite is getting a new feature called write-ahead logging, where it basically makes SQLite have multi-version concurrency control, kind of like real databases, where reads don't block writes and writes don't block reads. So at the time you go to read it, you get the version of the database that existed at the time you were reading, and then writes continue to be appended to the end. And then when that write is done, there can still only be one writer at the time, but when that write is done, it says, this is the new version number, and then the readers go and apply all the pages that were dirtied retroactively on top of it. So this will let you do things like write to a database from your provider without blocking, say, like Gmail scrolling your conversation list, where that's faulting it in from the SQLite database. And sometimes you can like kill your animations, or your activity was noticeably janky because it's blocked on the SQLite flock. So I think the concurrency out of write-ahead logging will be really interesting post Froyo. So the summary, we could do some more demos, is yeah, get off the main thread. Things are actually slow that sometimes you are fast. I'm sure your home network connection and your emulator or your phone on your home Wi-Fi is really fast. And emulators, if you have an empty device that you're developing on, that their disk is going to be a lot faster than users in the field with full disk. So yeah, basically assume things are slow, know what SQLite is doing, add your own instrumentation. Just because it's not auto-magically exposed to you right now, like through the market, you could totally do it yourself for your own apps, or put a little server on App Engine or something and upload performance data from your own users if they agree to that. So yeah, all the code is up that you could play with in these demos, and I think I'll also show kind of how slow I/O is on a real device here. Android. Kill the emulator. All right. Switch to this guy. This is another fun tool we wrote during Froyo that lets us measure various speeds of things, little micro benchmarks on reads and writes and settings and binder calls along things. So you can see like, a binder call between two processes was like 0.18 milliseconds, or here's a binder call returning a string, or content provider calls, or writing settings. We just did 1,000 of those. Reading files. So we were using tools like this to kind of measure improvements over time. Should have told me it was way up there. So that is in the open source tree whenever it is released in Froyo. So where's my I/O droid here? Alphabetical order is hard. There we go. So here's a random 1-byte read. So you can see it's like sometimes fast. So even a read jumped up to 139 milliseconds there sometimes. This isn't very scientific. This is just kind of fun. Writes, on the other hand, like 391, 200. That's like writing a single byte. I mean, maybe my SD card or my internal flash got full again, but it kind of jumps all over the place. Like a single byte writing was like 390 milliseconds. So switch back to this guy. One thing that's fun here is if you think like your internal caches are making your thing fast, you can always go to your device and say, need to be root. You go like echo 3 to process VM, I think it's drop caches, spelled correctly. And so basically 3 is a bit mask of 1 and 2, which is 1 is like inodes and 2 is like slab or something like that. I always just echo 3 to this and basically drops a whole bunch of the kernel caches. So then switching back to my app here, reads are like slow again. And so I can just sit up here and hit like up enter or paste, paste, paste. And I could like force it to be slow. Slow, 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 slow. So that's a fun trick too, to like simulate worst case. You should also just like put a big file on your data partition that makes your app like training in Denver. Like make your data partition really, really slow to simulate the worst case for your end users. And yeah, get your file system like 80, 90% full, and then you'll see like SQLite at its worst. Anyway, let's do some questions, and maybe we could jump around code if there aren't any questions. I think I saw a bunch on the wave. If there's live questions too, we could do those. All right. Let's go in order. Is there any plan for Nexus 2, or does it already exist? I have no clue. I guess the web store is shutting down, and I guess Nexus 1 is kind of a marketing name anyway, so maybe somebody will name a phone Nexus 2. I don't know. What is the most common performance problem you see? I think pretty much just people doing stuff in the wrong thread, I/O being slow, SQL queries that look innocent, but if you look at the table that it's selecting from, it's really a view of a subselect of a view. And you're like, what? It was just a select. Why is it slow? So yeah, I would say I/O and doing stuff in the wrong thread. I have no clue about Google TV, although I have one, and it's very fun. I can run my Android apps on it. Oh, this is a good one. Any rules of thumb to follow to improve the speed of UI draws when the orientation of the phone changes? So I actually bookmarked this one to point out there is something here. There's something called on-retain non-configuration instance, which doesn't sound like on prepare to rotate the screen. But that is effectively what it is. So rotating the screen is a configuration change. Basically, you have a whole new type of screen. Rather than a screen that's tall, you now have a screen that's wide. And because it's a different type of screen, you could have different layout files and different drawables and all this stuff. So the way the Android system works is if you don't declare in your manifest that you handle a certain type of configuration change, then by default, like your activity is just killed. Not your process, just your activity is shut down and reinstantiated with the new configuration. So if you have a bunch of expensive state in your activity, like network resources you loaded, or data, or JPEG, or the user was drawing something, and you didn't write it out somewhere, as you should, then when your application is restarted, or the activity is destroyed and reinstantiated with the new configuration, you have to load all that stuff again. So you have two options. You could either declare in your manifest that I handle rotating the screen, that I handle that sort of configuration change, or you could do this. Generally, you don't want to do that first one, because then you have to handle on, I think it was on configuration changed. And if this configuration is like, now I'm wide or versus tall, and those are different layout files, then you would have to handle like destroying all your views and changing everything yourself. Generally, what you actually want to do is destroy the whole activity and start it up again with the correct views that the system will inflate for you. What you don't want to do is redo all those heavy objects. So that's when you would use on retain non-configuration instance. Basically, this is called right before onStop and onDestroy, it says. And you can return any arbitrary object. This is like your expensive state. And then when the next activity is started right after you, which is the exact same one, you call get last non-configuration instance, and you restore your state that was expensive. So that is the answer to that question. How is Android 2.2? I love it. I really wanted to throw my phone against the wall half the time and declare. And I mean, this is why I joined Android. I was just like really frustrated by performance, like certain parts that just weren't responsive. One of my pet peeves that I got into Android 2.2, which is kind of a side thing, was that power control widget. Like it just wouldn't respond. Like you would turn Wi-Fi on and off, or Bluetooth on and off, and sometimes it would just hang, and like the UI wouldn't change, and sometimes there'd be a little toast. And because it was doing all really expensive things that went all the way down to like the kernel and drivers and Bluetooth and the PPP daemon, and that was all happening synchronously before any UI was ever updated. So I tried to make that responsive. There's still a couple buttons that aren't as responsive as I like in there, but the first 3 or 4 are pretty good. There's a whole bunch of other stuff. Basically, let's see if I have any reports here that we did. Nah. Basically, we just made tons of reports about all the slow parts, and we had meetings once a week after we did the weekend builds for all the Googlers. And we'd go on Mondays, we'd go and look at these reports and just be like, whoa, what is that thing? So yeah, I like it. There's still a lot more to do, but is that a question?
Yeah. We have an application that's downloading a bunch of thumbnails in a list view. Kind of 2 parts to this question. Do you have a good piece of code that kind of illustrates asynchronously downloading that stuff into a list view, or is there a good pattern to follow?
So I do. I open sourced it this morning, this little sample app. Apparently, I did one part of it wrong, so I'm going to go update the code. So yeah, so basically, here, we can go look at the code.
So the second part to that question is we have an implementation that's working. I think it's pretty fair, but it's downloading these thumbnails using the context get cacher, and just basically throwing everything into the cacher. And based on what you were saying about file reads and writes, is there anything special we should do? I mean, the documentation on get cacher says basically Android's going to manage this for you and delete stuff whenever it feels like it needs to. Is there anything we should do to kind of help?
Android's going to delete what part?
When you use the context.getCacher and just throw files into it, documentation basically says Android's going to manage this and delete files when it needs space. So is there anything from a performance perspective we should do to help it manage that? Or?
I think that's actually on a separate partition that's probably not very contended.
Okay.
So I think you're probably fine there. And also, raw files are actually pretty good. Sort of like one thing I didn't mention was if you're just like, sometimes all you need is raw files and you don't need a SQLite database, especially like log data. If you're like something like MyTracks where you're recording points over time, just inserting a row into a database over and over again, if you actually go look at proc YAFs while you're doing it, you could see that like it does a lot of operations like reads, writes, and erases to flash that just appending to a file doesn't. So it's not really totally relevant to your question, but I think cache is probably fine. Raw files are generally pretty fast.
Okay. Thanks.
But in terms of asynchronously doing something, in here I made this jankable list adapter where when I create it in the constructor, I can set my jank milliseconds. And in my get view, I do the proper like convert view thing. If one's being recycled, I use it. Otherwise, I inflate a new one. And I didn't do the pattern that they talked about yesterday during the list view talk to have that little struct. So I'm doing the correct way, not the fast way, where I look up the views every time. Like I said, I don't really do any UI work. But what I did here is, OK, so ignore the jank one. For the async stuff, what I do is set off an AsyncTask that just sleeps, just to kill some time. Post-execute, which happens back on the UI thread. The problem is after 500 milliseconds, or whenever I'm actually scheduled, because all async tasks run serially in one background thread, the view that I was modifying may be gone. It may be recycled because I was like actively scrolling. So I basically set a tag on the thing when I finally when I first show the view on the screen, I set a tag being like what position I'm at, and this gets I think that's like an object or something gets auto-boxed to an integer. And later, I check to make sure that it's still the same number, like that actual view instance is the right one. Apparently, you're not supposed to do this. So don't do that. But basically, the pattern is you do some async task or other thread from your get view, and then you go update your data set afterwards. So I'll go update this code to be correct. So, yep.
Hey, you recommended for long-running background I/O. I think you called it intent service. Was it? How far back does that go for OS versions that we're targeting?
I think that's pretty old.
Is it?
Yeah, we could check here. Intent service. Well, we'll find out whenever the Wi-Fi is cooperating. Since API 3, so yeah, old donut or something, cupcake.
Great, thank you.
Yeah.
Hey, the last app I worked on, we had to read in much data, and I tried out like SQL and like serialization and of course XML and so on. And it turns out serialization is awfully slow on Delvec. Maybe do you know if this is better in the Folio?
Probably. If it was CPU bound, it'll be a lot better.
Okay.
So. And if it's still really bad, maybe that should be done in native code. I mean, maybe we're already using libxml. The question was XML or some data structure. Was it XML? Yeah.
I tried XML, SQL, CSV,
CSV,
all of them. But it turns out SQL was the fastest because of the native code. And I tested it on the normal PC with the serialization of 10,000 objects. It was like 70 milliseconds, and on the Android device, then it was like 5 seconds, which was painfully slow. And on the Dalvik, and there was all triggering the GC, triggering the.
So even with JIT, sometimes things will actually be CPU bound and they won't be IO bound, but that's still something that you could do on a background thread and have a little progress indicator in your UI and actually set that background thread to a lower priority. There's somewhere in the API to reduce your priority of a thread, and that way the user can still use your app while you're maybe exporting to SD card or something like that.
How expensive are random access writes into a flat file?
It's about what I was showing here. They jump around. Switch the ammo. Like writing a single byte, which is about the same up to 2K or something on. It jumps around. Sometimes like 200 milliseconds. Sometimes like very few. It really depends how full the device is.
But it would be significantly faster than the equivalent SQLite update.
Yeah, generally SQLite will, when you append, like when you do a transaction, even if you're not doing anything, will still create a rollback journal, write a header to it, and then delete it at the end. So what this one slide was doing, where I showed the graph, this was actually the operation. This was creating a file, writing 512 bytes to it, and deleting it. And this is what SQLite does on every transaction, rather than not you write at all. So this bug is now fixed in SQLite, but not in time for Froyo, or it was too risky for Froyo. So post Gingerbread, all SQLite transactions will also be faster. Yeah, so that's another pattern. If you're going to conditionally write, and you're like, oh, I'll use a transaction, and then do my read, and then bail out of my transaction without doing a write, that's actually more expensive than you should do your read outside of your transaction, because reads outside of a transaction are a lot faster. Then go into your transaction, do the read again, double check that that condition still applies, and then do your write. Because if just entering a transaction involves disk I/O and it's pretty slow, and it also blocks out all of the readers on the phone. So, all right, I think we'll wrap up then. Thank you.